Okay, let's wrap up our discussion of at least the introduction to functions from section 12.1 by talking about when two functions are equal. And in a certain way, this is a straightforward question because, as we've seen in the previous discussion, a function is just a set. It's a subset of the Cartesian product of two sets, and we know how to tell if two sets are the same. They're the same if they have the same elements. So the basic definition of equality of functions is that two functions are equal if they're the same set. But this maybe takes a little bit of interpretation, so let's see if we can make any more sense out of it. So let me just remind you once and for all that a function f is a subset of the Cartesian product of two sets with the property that for every A there is a unique B with the pair AB in F. So we'd like to know something about when two sets are equal, and we can prove two simple propositions. For two functions to be equal, they have to have the same domain and they have to have the same range. So now that's not enough. There are lots of functions that have the same domain and the same range that are unequal. But at the very least, if they're going to be equal, they have to have the same domain and the same range. So let's start by proving that if two functions f and g are equal, they have the same domain. So because if we look at the ordered pairs, ax, which belong to f, every element of the domain of f has to occur as the first element of an ordered pair, ax. The set and the first elements are chosen from the domain. The set of first elements is precisely equal to the domain of f. So you can recover the domain of f by looking at the first elements that occur in all of its pairs. So if the set of first elements that occur in all of the pairs of f are the same as the first elements that occur in all of the pairs in G, that tells you that the domain of f is contained in the domain of G. But you can make exactly the same argument in the other direction. If every element that occurs in the first element of a pair in G, that's the domain of G, but G is equal to F, so all those elements also occur as first elements in pairs in F, and so the domain of G is contained in the domain of F. So this proves that the two domains are equal. Similarly, we are going to show that they have the same range. So remember what the range is. The range of F is the set of pairs X, is the set of elements X in B, so that there exists A in A with the pair AX in F. So suppose you take an X which is in the range of F, then you know there has to be an A in the domain of F so that AX is in F. That's what it means for X to be in the range. Since F and G are equal, the pair AX is also in G. But that proves that X is in the range of G because X occurs in the second element of an ordered pair in the set G. And this proves that the range of F is contained in the range of G, and the opposite argument is the same. These results are worth pondering, and they are described in the book. In certain ways, they are, maybe trivial is not the right word. They might even seem a little circular to you because it doesn't seem like we're using anything. But what we're really using is the careful application of the definition of a function and careful use of the quantifiers that go into those definitions. And by now, hopefully, those quantifiers are starting to sink into your mind. Now, as I mentioned, the converse is false. It is perfectly possible to have functions which have the same domain and range, but which aren't the same. So let me give an example of that, just a very simple example. So suppose our domain has two elements, 0 and 1, and our codomain B has two elements, 0 and 1. So here's one function. This is the function which consists of the pairs 0, 1 and 1, 0. So its domain is the set 0, 1, and its range is also the set 0, 1 because both 1 and 0 occur in the right-hand side. Now let's take two functions like this, and our function consists of the pairs 0, 0 and 1, 1. Also a perfectly good function. Also has domain 0, 1 and range 0, 1. But as you can see, the functions are not equal because they contain the two sets of ordered pairs are completely different. So what is true is that if you have two functions which have the same domain, then they are equal if and only if they agree for all x in that domain. So for this proposition, what this is saying is that so f and g are two functions. Let's say that f belongs to A cross B and g belongs to A cross C, and f equals g. So we'll prove one direction first. Well, the fact that they're equal means that if we take x in A, so then by definition f of x is in f. F of x here is the b which goes with the x in the domain. But since that's equal to g, that tells us that f of x is in g, but by definition, this is also g of x. It's the element that occurs in the second component in the ordered pair in g. And so we've shown that f of x equals g of x. Actually, we've shown that at least if x is in A, then f of x equals g of x, and then you can run this equality backwards to get both directions. On the other hand, what if f of x equals g of x for all x in the domain? So we know that if they have the same domain, so the fact that these are equal means that the pair x f of x equals the pair x g of x. And this one belongs to the function g, and this one belongs to the function f. So f exactly consists of the pairs x f of x for x in the domain, and g consists of the pairs x g of x for all x in the domain. But all these f of x's are equal to g of x's, and that tells us that these sets are actually the same. So two functions are equal if they have the same domain and they take the same values at every point on that domain. Notice that means that they do not have to have the same codomain. So for example, if I give you the function f from R to the interval 0, 1, where f of x equals sine of x, or in other words, the pairs are x sine of x for x in R. Or I give you the function g from R to R, where g of x equals sine of x. Again, you get the pairs x sine of x for x in R. And these sets are exactly the same set. And so the functions are the same, even though their codomains are different. So two functions that are the same have to have the same domain. They have to have the same range, but they may not necessarily have the same codomain, because the codomain could be quite a bit bigger than it needs to be.